Hi, thanks for tuning into this episode of QRP to QRO. This is video number 9, some ramblings about portable power systems. My name is Steve, and this video is going to kick off a series that I'm going to do on different subjects related to portable power systems, solar panels, batteries, etc. So in the past, with follow-up videos, I've done a decimal, like this is video number 9. I might do a follow-up as a 9.1, 9.2, etc. But I'm thinking more along the lines of just sticking to whole numbers this time. So instead of going from 9 to 9.1, go from 9 to 10 to 11 to 12 and so on. So if you have a preference one way or the other, leave me a comment and I'll check it out. So following this will be a presentation on some of the subjects I hope to cover in this series. They're not necessarily in sequential order, but just as opportunity arises and I get through them, hopefully I can get through all the different topics as we go along. Then following the presentation will be a history segment. So I've got some documentation on some of the trips I've been on, some of the types of setups and how I use these types of systems with all my own activities. So hopefully this gives you a lot of good information and you'll learn something from it. Stay tuned. So before I get into the video subjects a little bit later in the presentation, there's a couple of other tidbits that I wanted to cover up front here. So back in 2008 is when I started backpacking in college, and that's really the root, if I look at all the different aspects of things that have gone on in my world, that's really the root of my desire to have a portable power system, is going back to all those early backpacking trips and then trying to evolve that through the years. And then in 2014 is when I started distance bicycling. And I would go out for full day trips to go off exploring and see different areas. So more along the lines of bicycle touring than just going out simply for a exercise type bike ride. You know, I'd pack everything I needed for a day wherever I was going, whether that be, you know, food, clothing, you know, my GPS, and a lot of times I'd take ham radio gear with me too. So, you know, there was a lot of different things that I would include on my bike trips. And, you know, you combine all that together and keeping a phone charged and all that, it takes power. And that's really the root of where this idea of having a portable power system comes from. And hopefully, again, imparting some of that knowledge on the viewers of my channel. Hopefully they can get something out of it and be able to better prepare themselves for whatever type of power requirements they have. And that's really the goal of this, is being able to answer a lot of the questions that may lead into, okay, what do I need? Or, you know, is this going to be sufficient, etc. There's all kinds of things that you can look at and need to look at to answer some of that. So let's take a little bit closer look of my reference of what portable power is. And the way I'm using that here in this presentation and in my video series is it's a lightweight packable power solution for things that can run off of 12 volts DC, just like the power outlet in your car. So if you think about it, there's any number of things that you can plug into that outlet. It's not just an adapter to USB so you can charge your phone, tablet, iPad, Kindle, iPod, what have you. You can also plug in a power inverter. So if you have, say, a laptop computer that uses an AC wall adapter to charge it, if you use a small power inverter, you can get that AC off of that 12 volts DC. So really, depending on, again, the size of your system, etc., or what your power requirements are, you can size a power system to that, so you can satisfy whatever those requirements may be. So let's look into the weight a little bit. If you go back to my reference of portable power being a lightweight and packable power solution, I'll back up on that for a second, because there are a lot of people that do very lightweight backpacking. There's also a lot of people that are affectionately referred to as gram weenies that will go as far as to say cut the handle off a toothbrush to save space and weight. So if you're going out to be super light and super efficient, you can pretty well cross off your list some type of power solution to take along with you, because you're going so far as to cut out the need for having that power to begin with, and trimming things down to the very, very bare minimum of what you need to sustain for whatever type of hiking trip you're going on, or backpacking, what have you. So there's a lot of things that you have to take into consideration. And again, weight is a relative term. So what is it? What type of activity are you doing, and where does that weight stack into what that type of activity is and entails? So with that having been said, the environment in and of itself is a direct factor in how to plan the sizing of a portable power system. And as I mentioned in the beginning of the video too, the timing on the other videos coming in this series are up in the air. So it, just as I get through them, I've got several ideas right on the table that that I'm going to be working on following this video. So stay tuned, and subscribe to the channel, and subscribe to my Twitter feed as well. And when those subjects come, I'll post them up, and you'll get a notification on when those do show up, so you can view them as well. So my goal in this video series, just in other words here, is to illustrate practical knowledge you can use to guide selecting components to build your own portable power system. And practical knowledge is, I think, the key term to keep in mind as we go through all this. So a couple of questions leading into that. So how much power do you need? You really need to have some legitimate idea. So don't shoot in the breeze, don't leap for the moon, or stab in the dark. Try to figure out some legitimate idea of how much power you need. And to do that, you can use facts and knowledge to guide how you should meet whatever those requirements are that you define. But you have to find what those requirements are up front. And also, don't take anyone's suggestions, especially anyone trying to sell you products, for what you need. And also, don't take any suggestions directly from me either. Not that I would try to guide you into something directly, but again, use facts and knowledge to guide how you should meet what requirements you define. So that's, again, the ultimate goal of the presentation and the video series, is to give you that knowledge, and hopefully that'll allow you to get through your ideas of sizing a system to meet whatever particular needs that you define. A couple other things of note is, of course, reducing power needs will reduce space and weight requirements. That's a given. There are things that you can do to reduce some of those power needs, and we'll get into that a little bit later in one of the following videos. The length of time for how you run gear off your power system will also guide your requirements. So, if you're running, say, a cell phone on a camping trip, that's 5 days. If you turn that phone off, say the majority of the day, and maybe 2 or 3 hours, or 2 or 3 points throughout that time, you power up your phone and check your texts and emails, etc. If that phone's not on constantly, that's going to reduce the amount of power that you would require for whatever that situation is. So keep this idea in mind from the very beginning, is power sustainability. The idea here is the same as off-grid. Can you maintain your power system indefinitely without auxiliary means, meaning commercial power, charging from a vehicle, charging from a larger AC, portable generator, etc. So power sustainability, that's something to keep in mind. So a couple examples of different power needs in a portable setting. So the first one is after hiking and packing in gear 10 miles into the wilderness to set up a base camp, are you going to have power to recharge your flashlight, headlamp, GPS, keep power to your ham radio gear, and be able to charge your phone on day 3 of a 7-day trip? What about days 4, 5, 6, and so on? And again, that basic idea of power sustainability, can you keep going and replenish? Example number 2 is you drive into a national park and set up your RV for the weekend. You throw your day pack on and go for a 6-mile afternoon hike with the family. Halfway through the hike, your GPS quits. At that point, you realize you forgot to charge the battery as you were tending to your 5-year-old who had a meltdown at breakfast because his bacon was too close to his eggs. So, 2 totally different environments, 2 totally different requirements, and, of course, 2 totally different mindsets here. And again, that all goes into what type of power do you need, or how much power do you need, what type of system is going to satisfy whatever those needs are for that environment. So clearing up a couple of misconceptions. Power packs, high capacity batteries, power banks, all of those, whatever you want to term them, for charging USB devices. Those are great for maybe 1 or 2 charges throughout the day. But they're really not designed to be something that you can sustain on, because again, how are you going to replenish it? If you only get a couple of charges and then you've got to plug it in to an AC outlet, again, power sustainability. You don't have power sustainability on any of those such devices. Even the solar power packs, they are a step above the basic ones that just plug in. Because they are kept charged all the time. As long as they're exposed to light, you always have it ready to go. You don't need to charge it before a trip. It's usually, you just pick it up and you go. But you're still limited to whatever the capacity is of that battery system that you're using. So if you can get, say, 2 charge hits out of a non-solar powered one, and you have the same capacity in your solar powered pack, you're still limited to those 2 charge hits unless you can recharge completely in between those. So, going back to power sustainability, if the only thing that you're wanting to keep charged on a hiking trip, for example, or a backpacking trip that's many days, is a cell phone, and you're not keeping it on all the time, you just turn it on every so often, then you may be able to get by with something like that. But in general, if you're using something that consumes power routinely, again, those are not going to be sustainable power choices. For those in the cycling community, it's really popular to run hub dynamos, which those are basically a generator that's built into the front hub of the bike. And the reality of it is they're such low wattage that you really can't get a high amount of power out of those. They're an awesome idea. There's a lot of people out there that run them. The main benefits to using those are for lights, such as headlights and tail lights, as you're riding the bike. You never have to worry about charging batteries for lights. There's some newer systems out now that have the ability to run USB charging off of that too, for a phone or a bike computer. But if you're trying to charge a 12-volt battery, if you're trying to run other equipment, you really don't have the wattage, and we'll cover that a little bit later in the video series. but you just don't have the wattage or the voltage available on the hub dynamos to do a whole lot with them. Again, they're great for low power lights, being the main thing that they're good for. Okay, so getting into the coming subjects for the video series here. One of the main things, again, I want to point out is practical operational knowledge. So a lot of this, again, going back to even prior to 2008, but just through the years as I've been an amateur radio operator and into backpacking and cycling, these are some of the things that I've picked up on, and that's really the root of the material that I'm presenting here. But most of it will be conceptual, and it won't be very math intensive. But there will be some calculations based on Ohm's law, including power, meaning wattage. There will be some schematics, component specs, and measurements as we go along. Shown some of the oscilloscope traces. That's really an excellent tool. You can actually expand out the time base in an oscilloscope wide enough that you can see the voltage rising even in DC. Just as the charge state of a battery increases. So we'll cover some of that a little bit later on. And there won't be any long-term studies. I will get into a little bit of battery chemistry and as batteries age, but it's not going to be really rooted in long-term studies. It's just the effects of, so more theoretical, I suppose, but there will be some measurements and simulations to describe some of what is to come. So again, theory that practically applies. As I mentioned, we'll do a little bit of talking on battery chemistry, mostly meaning the lead variants. That's your AGM and SLA type batteries, as well as lithium iron phosphate. That's the LiFePO4 type batteries. We'll talk a little bit of battery health. So storage capacity decreasing with age, poor maintenance, as well as short-term self-discharge, minutes to hours during intermittent use and not days of storage, and how that gets worse over time. More on charging here. One of the main things that I've incorporated into my setups is the ability to charge off of solar power. And we'll talk a little bit on really any conversion of mechanical energy for charging only, whether that's AC rectified to DC or just straight DC, but not running anything directly off of that, just strictly the mechanical conversion to electrical for the purpose of charging a battery system. And that could be wind, hydro, engine-driven, pedal power. It's really all, when it comes down to the conversion to electricity, it's really the same. And of course, going into the battery, the different battery chemistries absorb that power differently. So when you get to, again, that mechanical to electrical conversion, it really doesn't matter what you're powering that with. We'll also talk about the importance of working with averages and why storage capacity is so important. And as you see, that's highlighted in yellow and very big to make a pretty strong point about it. This is getting into the balancing of a battery's ability to store power versus how much is sent to it. And why trying to size peak production to peak power consumed doesn't work very well without storage capacity. So the main idea there is the ability to store the amount of power that you're generating. So again, getting into some basic calculations, wattage, as that pertains to system efficiency. So we're talking consumed power, how much is used, lost power, meaning resistance, as well as power to run the charge controller and any other electronics. So it's one thing that, especially on the smaller wattage systems, you really need to pay attention to as you're looking at that larger picture of, how much power overall do I need and how do I size the system. And all the principles that I'm covering here, I'm speaking on a small scale, but if you think through the overall idea of the different parts of the systems, let's take solar for example. The amount of solar power you have, the amount of storage capacity you have, and the amount of draw that you're going to be putting on that system, all of those principles really do apply to systems of all sizes, so long as you do have some type of storage. And what we won't be talking about is the idea of a grid tie system, which is where you're not storing power, but you're backfeeding a power grid, just like you have at your house or place of business, etc. This is all, everything I'm covering is all portable and using a bank such as batteries to store that electricity and to run your equipment off of. We'll get into the micro M charge controller. That's one of the main things that I have with my system and have for many years. There's quite a while where I wasn't using it and just feeding directly into the batteries and monitoring that voltage. But the micro M Plus really is an awesome little kit. You can homebrew them also, but we'll get into those. And they're, again, mainly meant for small solar systems. I think 4 amps of current in a 12-volt system is about the max that's rated to. So we'll talk about that as it was designed in normal operation. And then I do have a few ideas through experimentation of how you can actually modify that to control higher power charging sources. I might put an asterisk there because you are adding power loss because there's other components that you need. The Micro M Plus itself, with the components it was designed with, won't handle a whole lot of power, but you can use the voltage sensing ability in that circuit, and we'll go over that a little bit later on in the video series. So with that, we'll move on to the history of my setups. So before I get too far into the history segment, I am using a screen recording software. And if you see my mouse cursor on the screen, I'm going to use that as a pointer as I go along. So kind of look out for that as I'm talking about different subjects here. But earlier in the video, I did mention one of my main roots of interest with portable power systems stems from backpacking starting around 2008. So I thought I'd put some pictures in here of that very first backpacking trip, as this is a history segment. And back then I started on the amateur radio side in my backpacking with using the Yaesu 857D radio, which you see here. I was running 40 meter CW, it looks like. That's on 7.026 or 7.028. But I had mentioned earlier also about the aspect of weight with portable systems. And the tuner here to the right is the MFJ 971. And as you see, I don't have the case on it. I had taken that off to save a little bit of weight, which it did help a bit. But if you consider the overall system, meaning the radio, the battery, and the tuner, antenna, all of it combined, that was definitely not a convenient backpacking type setup, although I did make it work for quite a while. In fact, I used it for a couple of years. So between the radio and this is an early smartphone that I had at the time, which was a Windows mobile-based unit. I don't remember who made it, but it did have one of those slide-out keyboards on it with the actual buttons you push and not the touch screen like you see on iPhones and Androids today. So between the radio setup and keeping my phone charged, those are the two things I was trying to power out in the backcountry. And if you saw my video number 3 and 4.1, video 3 being the QRP operation, and then 4.1 is a overall video of the bike trip that I did that particular day. The antenna I used in that was the same NorCal 40 dipole or doublet antenna. And this particular backpacking trip was the first time I'd used that on a trip like this. I had set it up previously just at home, but as far as going out somewhere and setting up, this backpacking trip was its first scene, so to speak. And that's actually why I made it, because I wanted a lightweight option as far as antennas go that I could throw in the backpack. And it does work okay for that. And I'll show you another antenna coming up in a bit that I've used more often than the NorCal 40. But this was the first night. So this is a 3-day backpacking trip, again in the Monongahela National Forest in West Virginia, up in the Appalachians. So this was, I want to say that was the morning of day 2. I could be off. That could be sometime before the sun got too low on the evening of day 1. But I think that was starting out our day number 2. This is the morning of day number 3, the last day, so after night number 1. As you can see with the frost on the ground, it did get pretty cold that night. It was, I don't want to say any lower than 25. I'd say it was probably in the upper 20s. But of all the backpacking trips I've done, and I've even been in the same area snowshoeing with about 4 feet of snow and temperatures down to 0 before with proper equipment, and I've been nice and warm. I'm going to back up a second here. This being my first backpacking trip, I used one of the old sleeping bags I have, which is nothing more than a summer weight bag with, it's just a rectangular style. It's not a mummy style. So I added a bunch of layers, base layers, and the blanket you see there, and the heavy wool socks, just trying to add some extra insulation to combat the cold temperatures, but it still wasn't enough. That particular day, the third day, I got up before anybody else and couldn't wait to get that fire going to warm up. I'd never been so cold and stiff before. Then looking above the tent, you can see the antenna set up, the same 40-meter NorCal doublet. And then looking down the trail on the way back out, that's, again, day number 3, so we only had a couple of miles left to go to get back to where we had parked. But you can see how the feed line for the antenna snakes around and comes into the front of the tent there. And this was the Zaleski State Forest in Ohio. Let's see, that's March of 2009. So again, the 857 radio. And one other thing to point out about that, if you look at some of the newer radios like the Ellercraft offerings, the KX3 being the main one I'm thinking of, also the KX2 that came out, the earlier KX1, and then ICOM's 705. I don't know if they've actually put that into production or if it's out for sale just yet, but they adopted that same controls on the top type design. And one of the nice things about the 857 radio in its day is it was a remote faceplate radio. So as you see there, I'm operating it with the faceplate off the radio, which is a lot more ergonomic and convenient in this type of setting. So it's interesting to see a lot of the new radios are adopting that same type of design. And again, another look at the radio there. In that same camp, we were able to talk to a guy in Italy on the radio. The guy I had been backpacking with was not a ham radio operator at that point in time, but that was the event that pushed him into getting his ham radio license also. So you never know, anytime you have the opportunity to take somebody in the backcountry or show them something different, you never know what type of impression you're going to make on someone. And another thing I like doing on all my trips, and even going back to ham radio and a lot of other aspects of what I do, is I like to play around with different things and experiment and build my own things. And this is actually a stove that I made out of a couple of pop cans that runs on alcohol. So I played around with those for a couple of years. I haven't done it too much in recent times, but they're neat. They work. You can cook on them, and it's neat to make things and see them function. And again, the battery for the power system there at that time was a 12 amp hour SLA. And, for a 2-day or a 3-day backpacking trip, if you're not using, and again, I'm using an 857 radio, which is not really a portable class. I mean, it is, but it's not a QRP class radio that has real low current consumption. So when we're talking about like the Appalachian Trail specials or the Ellercraft offerings, the KX2, the KX3, those are in a whole other category, and even the Appalachian Trail specials, those are in a totally different category of radio completely than even the Ellercraft ones, as far as power consumption goes, and compactness and being lightweight. But when you consider the 857, there's other radios like the 897, even the ICOM 703. There's a lot of smaller, I'll call them not tiny, but smaller portable radios that are all kind of in this same class as the 857. If you look at that, receive current consumption might be about a half an amp to 3/4 of an amp. And if you're operating conservatively on power, maybe, 10, 15, 20 watts max. For a 2-day trip, a 3-day trip, for a little bit of operating while you're in camp, you can get by with a 12 amp hour class battery. That's what I did for a while. The catch to it is you need a battery that's obviously fully charged before you go. And then number two, in good health. If that battery is old and it's not holding a charge very well, you may be able to put a full charge into it. But over the course of, say, even an 8-hour or 10-hour drive to get to where you're going, if you set up camp on that first night, you're not going to have that charge in the battery when you get there as when you had it fully charged before you left. So then you get into, again, how do you replenish that battery, either after it's self-discharged or if you've depleted it in operation, and hopefully it's a quality battery that's in good enough health that it's holding up to the charge. But again, you can only go so long on it before you need to recharge it. So then another view of the pop can stove there. And that particular dinner was pizza pasta. Those are my ingredients there. That was one of the staples I did back in the day. And this was also Zaleski. That's May of 2009. And why I bring this one up is, again, the same radio, the same battery, and it's a different style antenna I used. It's a jumper dipole. I'll show you that here in a second. But that particular trip, we got all the way to that first camp, and I realized I forgot the power cable. So, of course, with backpacking and ham radio and a lot of other things, sometimes you have to think outside the box. And I happen to have metal tent stakes with me. And early on when I got the 857, one of the very first things I did with it is I cut off the power pigtail that had the 6-pin Yaesu modular or Molex style power connector on it. And I put power poles on it. One of the best modifications I ever did to that radio. And as you see, the tent stakes just happen to fit right up inside there fine. And the one on the ground side wasn't making a very good connection to the battery, so I used this stick to put a little extra pressure on it. And it actually worked out fine. It made enough connection that I could sit there and listen to the radio and run 10 or 20 watts, and it didn't give me a whole lot of problems. Of course, you got to be careful not to short out the stakes, but hey, in a pinch, it'll get you on the air. Again, sometimes you just have to think outside the box. That's a Go kit that I made with the 857, obviously, and that same 12 amp hour battery. And here you can see that other style antenna I was talking about. That's a jumper dipole with the coax being a run of LMR 200. And the antenna itself was made out of speaker wire. I want to say it was about 20 gauge. And if you look at the blue connectors on there, I only used this antenna for about a year, maybe a year and a half. And those crimp-on connectors, I use spade connectors in between all the sections. After a while, the metal fatigue on the copper, again, it was maybe 20 gauge solid copper. I spent more time trying to repair those connections than I did playing around on the radio. So I ended up retiring that option, and I've rebuilt it. This is version number 1. My version number 2 uses some wire from the Wireman. It's silky wire, they call it. They're 26 gauge. And they call it silky wire because it's stranded copper-clad steel, and it has a Teflon jacket on the outside. It's extremely tough stuff. And in post-edit, I'll put a tag on this so you can see what the part number is of it. But it's absolutely fantastic wire. In fact, I bought a whole spool of it probably 5 or 6 years ago at Hamvention, just so I'd have enough to play around with on different antennas. And I've made a jumper dipole out of it. I'm using a long wire as I speak right now that's made out of the same stuff. I've used it numerous times for other ideas, but as far as durable antenna wire, you just can't beat it. And of course, with any portable antenna or emergency kit, it's always good to have a run of 550 cord available. So back to the power subject, which is obviously the topic of this video and the presentation here. One thing that you do not see in this picture is anything that makes this a sustainable power and consumption type system. If you look, the only thing to recharge this battery is a plug-in charger. So going back to what I mentioned about power sustainability, once this battery is depleted, whether that's in this Go kit, as nice as it looks and convenient and complete as it may be, once that battery dies, it's still reliant on some method of recharging that isn't in that kit. So that could be an automobile, a car with a power inverter. That could be a generator, a fuel-burning generator if you have access to one in an emergency situation. Or that can be AC mains power. None of those are sustainable options. So when we're talking about, in my reference of this video, sustainability, we're talking solar power, the ability to convert some type of mechanical energy into electrical energy. Those you can run without, say, AC mains power. You're not relying on an alternator off of a generator. You're not relying off of a car. You can pack a small system together. Even within this same size case, you could put in the 2 solar panels I have and the charge controller, and you could turn that very well into a sustainable power solution and ham radio solution in this case. Whether you're running a radio or you want something to charge your laptop computer or cell phone or tablet, it doesn't really matter what you're running off of it. All electronic devices take power, so how do you accomplish that? That's really the question. This picture is actually sunrise, and that is in the Smoky Mountain National Park. Let's see, that was October of 2012. And you saw this in the beginning of the video too, the quick introduction slideshow that I did, but that is actually sunrise. And if you're familiar with the Appalachian Trail, this is the same mountain where Clingman's Dome is, and Clingman's Dome is the highest point on the Appalachian Trail. And back in 2012, we did a trip down there, and that was the beginning of it. So we started early in the morning this particular day, and I just thought it was a opportune time to do a little photo shoot there. And this is actually the first trip that I took the KX3 on. And again, going back to the 857 before, that's what I was using in the early years of my backpacking. And it's, again, not really an ideal backpacking type radio. Yeah, it's small and compact compared to some other boxy radios. But from a lightweight, packable perspective, it's obviously pretty heavy. I'd say with the 857, the battery, the antenna, the tuner, the whole 9 yards, that setup was between 15 and 20 pounds. So if you think about a backpacking trip, if you're going out for, say, 3 days, and a typical pack weight might be, say, 35 to 45 pounds, if we take the high end of that, say 45 pounds, and then you add, 15 pounds of electronics and a battery, you hit 60 pounds pretty quick. So with the KX3, again, it being a little bit different class radio, it doesn't have the power requirement that the 857 does, so you can get by with a smaller battery. The other thing that you'll notice is the iambic paddles on the bottom of the radio. The ones I was using, I'll back up a second here. Before was the Vibraplex Code Warrior Junior. Absolutely fantastic set of paddles, but it's heavy. It adds weight. So, there again, you have the paddles built onto that particular radio. And another nice thing is they have built-in tuners in them. So going back to an antenna such as the NorCal doublet, instead of having an external tuner like the 971, I have the built-in tuner with the KX3, and maybe if you're using a balanced line-fed antenna, you need to use a balun with that also. Well, you can add a balun to that setup that's very lightweight. In fact, I've got one that I built onto a BNC plug specifically for that type of application. Works fantastic. Yeah, it takes out a lot of the additional weight of that overall system. So if you look at, decreasing the size and weight of the equipment that you're running, you can also decrease the size and weight of the power requirement, meaning the battery, or if you're considering solar panels or some other means of being able to charge on the go. The less that you are requiring, then the less you need to supply. So it all gets into that same equation of how much do you want to carry, whether that's stuff just in volume or the weight side of it also. And that also gets into the differences between the lead batteries, meaning the SLAs and AGMs, and lithiums, lithium iron phosphates. You have a lot less weight for the same, and even a lot more power capacity in a lithium battery. So a lot of things to consider when you're looking at power systems. Again, it's all a matter of what you're trying to power and how much you need, and what your overall goals are with it. This was in the Monongahela National Forest, again in West Virginia. I want to say this is in 16. Let's see, yeah, that was New Year's of 2016. I've actually been out to this particular campsite quite a few times. It's one of my favorite places to go. And again, the KX3 is the radio I was using. With you only see the one solar panel here, the big one, but if you follow the wire down below the multimeter here, I did have the smaller one on the other side of the ledge. And going back to the idea of battery health, this particular trip I had bought a brand new SLA, which is a 9 or a 7 amp hour. I'll have to check it again. But the one I had been using up until that point had a few years on it, and I didn't think it was holding a charge very well. So I thought instead of trying to risk it on this particular trip, I'd go ahead and trade it in and start with something that was fresh and I could rely on it a little bit better. So it was a good idea to do that just before the trip. And in fact, that's the same battery that I had run ever since. And up until I switched to a lithium battery. I still have this one, actually. That you'll see that here in a minute. And it does hold a charge. It's not quite 100%, but it's still a usable battery today, and that's what, 16 to 20, so 4 years. There's a view from that particular ledge, and actually going back to, I guess it would have been 2009, spring of 2009, we did another backpacking trip out to the same area, and there's another site that we went to that was just to the left of where I am, maybe about a quarter of a mile. And I'd always wanted to get back to that campsite. It was one of the favorite campsites of any of those early trips between 2008 and about 2010. Of all those campsites I had been to, this is the one area that really stuck out to me. And on one of the years I went to this campsite, the one I'm sitting down at there, I decided to hike over to the other one and see if I could find it. And it was just overgrown and nothing but game trails and bushwhacking to get to it. But I did eventually find it. So, and again, it's overgrown and it's not a usable campsite right now. But with a little bit of clearing, it could be usable again. It'd just take a lot of effort. And there's another quick view of that same ledge operating the KX3. The three bands that I usually operate if I'm out on a trip like that are 17, 20, and 40. So my guess is, during the daytime like that, I was probably on 17 without a doubt. Then again, going back to the beginning of the video, I started distance cycling in 2014. This was May of 2015 on the Illinois and Michigan Canal Trail. So I lived out there for a few years and did a lot of riding east and west along that Illinois-Michigan Canal Trail between about Joliet and Starved Rock State Park. I guess that was about the furthest west that I ever made it to. I want to say that was the town of Panama sticks out, but I know that's not the name of it, but it begins with a P. Anyway, it's east and west between Joliet and the Starved Rock State Park. But this is one of my trips out there, and I'd go anywhere between 25 to 50 miles out, and then stop for lunch and to relax a bit. I always took my hammock with me, and would cook lunch, etc. So when I stop, of course, that's an opportune time to recharge the battery, and that's what I did here. I just put the small solar panel out, and so you can see the battery on the back of the bike. So any extra power that I could push into the battery was always a good thing while I had the opportunity to. And this picture is also on the Illinois and Michigan Canal Trail, and that was in 2016, October 2016. And I'll pause on this one for a minute, but a couple things to point out on the bike. Power-wise, the red thing that you see is a tablet. I run an app on it called Gaia GPS. And it's really meant for backpacking and hiking, as it has a lot of topo maps that you can put in it. But it does have street and trail maps that you can load. So it works just fine with cycling as well. And the neat thing about it, and one of the reasons I use it so much on the bike, is you can take all those tracks and overlay them. You can turn them on. So if you want to see all the rides that you've done over the course of a season, you can turn them all on and you can see them right there on the screen and move the map around, etc. So it's pretty neat. So between the tablet, the phone, the bike computer I use is a Garmin, an Edge 1000. Those are the three main electronic devices that I keep powered on my bike trips. But I also like to run a handheld ham radio a lot of times while I'm out on the bike as well. So sometimes, that could be a fourth device that I'm powering. So all of that, again, it does take power to run it. And onto the solar panel with this one, I was riding back, and this was later in the evening, and I was running low on power. So, of course, when I had set up for lunch at the halfway point, I had things charging, but I still was depleting that battery. So I thought, just for the heck of it, I had found that stick. It's mounted to a stick that has a Y in it on the back of the bike. I just duct taped it to the stick. I thought, I'm going to try something on this ride, and I strapped the solar panel to the back of it and tried to scrape some photons as I was riding back. And, hey, it's not a practical solution, but I had the opportunity there, and I decided to try it and see if it would work. So I got a little bit of power out of it, but again, it's absolutely not a practical solution for actually riding on the go, so to speak. But it was fun. And this was in, November of 16. That's the Wapansi Glacial Trail that goes south out of Joliet to Kankakee. And this is actually sunrise. So I started that particular trip about 3:30 or 4 in the morning. And I thought, I'm going to ride as far as I can before the sun comes up. And when the sun starts coming up, I'm going to stop and set up breakfast and get some sun rays for charging the battery at the same time. So that's exactly what I did. So I cooked breakfast and got a little bit of first rays of the day to charge up my battery some. And this was the same trip. That was later in the evening. You can see the shadows are getting long. But I decided to take the small solar panel and strap it to these sticks you see. And as goofy as it looks, this is actually a really good setup that I used for probably about 6 months. The nice thing about it is it's lightweight, and B, depending on how I have the gear on the back of the bike and the direction I strap it down, I can angle that to capture a little bit more intensity of the sun. So, of course, with the angle the bike is right now, I just leaned it up against that fence for the picture, but you can angle that so as the sun gets lower, you can get a little bit more efficiency of that charge current. I mean, it's not going to be a 100% solution, but if you consider being able to ride the bike with that, say, flat across the back versus angled, you're going to get a noticeable improvement of charge current if you can do that. And again, most people would say that's not a practical solution. Why not use a hub dynamo? But I'll cover that in one of my follow-up videos in the series too, because there's a big wattage difference between the two types of devices. And another look at the same setup there with the solar panel and the sticks. And I believe was the same trip. Yeah, Wapansi in November 16. But when I stop, I put both the solar panels out to get as much juice as I can. And this was in November of 19, so this was towards the end of last year. This is in Ohio. I rode several miles to some family on the other side of the state. So this was day 2 of a 2-day trip. And I did kind of the same thing with the small solar panel, draping it over the equipment on the back of the bike.
And this time I didn't have any sticks to strap it to, so it was just kind of flopping in the wind. And I mean, it gives you a little bit of power with it being overcast that day. The combination of it being overcast and the loose solar panel didn't amount to a whole lot of power, but you know, better than absolutely nothing. Then again, if you saw my video number 3 and 4.1, the bike ride, this was the setup at that particular time. You can see on the left side behind the red bags on the left, I've got both the solar panels out, and that was my QRP setup. Just trying different radios and different setups. Actually, the 971 tuner, that's the silver one on the bottom, was not working that particular trip, and actually one of the capacitors had been bent inside, one of the plate capacitors. So I took it apart when I got it home, and I fixed it, so it works fine just now. But yeah, in video 3, the QSO in the portable operating, I was using the LDG tuner on the top, the Z11 Pro tuner. And again, the NorCal doublet going off the back right corner of the picnic table. That's the same one I used in that first backpacking trip. And another look from another trip at that same place, both solar panels together. And as you notice, it's a bit of a cloudy day also. So of course, the less light that you have, the less efficient the solar panels are going to be. But you can still get some juice out of them. So it's still providing some power, just not near what it would during the daytime, or in full sun, I should say. And the bike too, I'll point that out real quick. That's a Dayhan Mariner D8. It's a 20-inch folding bike, which I got for traveling, meaning to fold it up and put it in a suitcase or take it in a car or wherever. And it is actually a pretty capable little bike. I put panniers on it, as you see here, and it holds up just fine. So it's a nice little zippy, capable bike for some of my adventures. And this is the end of the history segment, but this is the current setup of the solar panels. And here you can see that same battery that I got new for that trip in 2016 to the Monongahela National Forest, the SLA battery, which it still holds a charge today. And in the blue box is my Micro M Plus solar charge controller. So I had built one of those somewhere between, I'd say, 2010 and 2012, because I was getting into the solar type systems. And at that point in time, it was just the small solar panel I had. So between that and the Micro M Plus controller, and then whatever SLA battery I happen to have, that was what my portable power system consisted of. I didn't have this bigger solar panel at the time. So both of the panels combined, they're about 17 to 20 watts, depending on how strong the sun is. But when I first had this Micro M Plus controller going, I bought it as a kit and then soldered it together with through-hole components. And I put leads on it with power pole connectors for the input and the output. And the one thing that I never did was put it in a box. It was just an exposed circuit board. And after replacing some of the transistors on it about 3 times, I decided, the next time I rebuild this thing, I'm going to put it in a box. So I finally got around to doing that here at the beginning of 2020. And that's what you see there. And while I was at it, I put that meter on top, and it's a pretty nice setup now. So I'll talk about that a little bit later in one of my video series, because as I mentioned before in the PowerPoint presentation, it is a little bit limited on the amount of power that you can put through it. I want to say it's about 4 amps max, but there are some things that you can do with it to use the voltage sensing ability of that, and then switch an external setup for a lot higher current to charge off of, with that same voltage protection that you have with the standalone Micro M Plus. So another thing to mention too is the idea of being able to charge devices on AC power. And take a laptop, for example. If you have a laptop that has an AC plug-in wall charger, but you have a 12-volt system, you can get one of these small power inverters and be able to charge that system with the same type of power that you're using, say for your phone off of USB, or if you have any other accessory that runs on 12 volts. The power inverter, just in this case, it's a design that plugs right into an automotive round accessory plug. So going back to what your type of environment is with the power system, if you're backpacking, then 99% chance you're probably not going to run into this. But if you're camping somewhere else, car camping, or doing some other activity, or you just want to have a backup type power system, and you want the ability to charge devices off of AC power, then this certainly could be an option for you. And this type of power inverter is, I want to say, about 120 to 140 watts of power. So again, for powering that fan, or if you want to charge a laptop off of it, it's perfectly suitable. Probably not something that you're going to go backpacking with, but certainly an option that you can use to run off of your power system. So with that, that brings us to the close of the history segment. We'll go ahead and wrap up this video, and I appreciate everybody paying attention and hanging on so long. So with this being a video series, again, there's going to be more subjects down the line. And as I questioned in the beginning of the video, I'm not 100% sure which way I want to go with the numbering. So I'm leaning towards more the whole numbers, so maybe 9 to 10 to 11, as opposed to the decimal system going from, say, 9 to 9.1, 9.2, etc. So if you have any suggestions or comments one way or the other, leave me a comment below and I'll check it out. So with that, I appreciate you guys staying tuned. This is episode number 9 of QRP to QRO. Some ramblings about portable power systems, maybe a little bit more rambling than not, but stay tuned for the coming subjects. I think you'll find a lot of good information to come. My name is Steve. My amateur radio call sign is KC8QVO. You can also follow me on Twitter at QRP to QRO. And as always, subscribe to the channel if you found this interesting or informative, or it's helped you in your own amateur radio endeavors, or even just portable power systems in general. If you have any interest in that, hit the subscribe button and stay tuned.